The late 17th century saw remarkable developments in European astronomy, spurred by brilliant minds and new observatories. In 1680, a spectacular comet appeared over Western Europe, startling people who considered comets harbingers of doom. Gottfried Kirch first reported this great comet of 1680, prompting Jean-Dominique Cassini and John Flamsteed to measure its path and send data to Isaac Newton. Their observations helped Newton refine his theory of gravitation, later showcased in his Principia 1687. Initially, Newton thought two separate comets had appeared, but he later admitted his error and concluded that this comet followed a parabolic orbit, with the 575-year period having previously been visible in 44 BC, the year Julius Caesar was assassinated. Around the same time, Edmond Halley financed Newton's publication of Principia and conducted extensive comet research. He noticed that a certain comet reappeared about every 75 to 76 years, having been seen in 1531, 1607, and 1682. Predicting its next visit in 1758, Halley thus cemented his name in history, though he died before its return. This verification of Halley's comet supported Newton's universal gravitation, inspiring figures like Benjamin Franklin, Thomas Jefferson, and Voltaire to pay attention to astronomy. The Danish astronomer Tycho Brahe had previously provided foundational data that shaped future research, including Johannes Kepler's 3 laws of planetary motion. Kepler compiled the Rudolphine tables from Tycho's measurements, although discrepancies emerged when comparing predicted versus observed positions of Jupiter and Saturn. John Flamsteed, as England's first astronomer royal, scrutinized these differences. Newton proposed that they arose from the gravitational interactions of the Sun, Jupiter, and Saturn. But no one could fully compute this three-body problem until the time of Joseph Louis Lagrange and Pierre-Simon Laplace in the 18th century. Meanwhile, Christian, Huygens, and Cassini explored Saturn's baffling shape and its moons, discovering Titan, Iapetus, Rhea, Tethys, and Dion. Cassini also observed the notable gap in Saturn's rings today, called the Cassini division, using the era's most advanced telescopes at the Paris Observatory. James Gregory, another eminent mathematician, proposed using infinite series to calculate trigonometric functions and suggested a method for estimating stellar distances by assuming all stars shared the sun's luminosity. Such ideas led eventually to Olbers's paradox, which questioned why the night sky is dark if the universe is infinite and filled with stars. With the establishment of national observatories in Paris 1667 and Greenwich 1670, astronomy entered a new phase. Scholars like Tycho, Kepler, Copernicus, Flamsteed, Halley, and Newton laid the groundwork for modern celestial science, forging a path that has led to our advanced understanding of the cosmos today.